Assalamu alaikum everyone. Today we are going to do 9709 February March 2025 S1 Statistics paper 5. Let's continue to the first question. The first question says that Jacob throws 3 coins at the same time. Okay, 1, 2 and 3. The first coin is biased so that the probability of obtaining a head when it is thrown is 1 by 3. So the probability of head is given to you as 1 by 3. So the probability of having a tail, it will be 2 by 3. The second coin is biased, so the probability of obtaining a head when it is thrown is 1 by 4. So probability of having a tail is 3 by 4. The third coin is biased, so that the probability of obtaining a head when it is thrown is 1 by 5. So obtaining a tail for the third coin, it will be 4 by 5. The random variable x is the number of heads. So the random variable is the number of heads obtained. Show that probability of x being 2 is 3 by 20. Probability of x being 2 means that there are 2 heads when you are throwing the coins, throwing the 3 coins. From the 3 coins you are obtaining 2 heads. So how is that possible? Let's write down the options first. The options are head and tail. The other option is head, tail and head. And the third option will be tail, head and head. So obtaining the probability of having a head from the first coin is 1 by 3, followed by another head of the second coin is 1 by 4, followed by the tail of the third is 4 by 5. This is the first option, plus the second option is having the head from the first one. So having the head from the first one is 1 by 3. Having a tail from the second one is 3 by 4. And having a head from the third is 1 by 5. Plus having a tail from the first is 2 by 3. Having a head from the second is 1 by 4. And having a head from the third is 1 by 5. Now if we simplify, 4 and 4 will cancel out, 3 and 3 will cancel out, 2 times 1 and 2 times 2. So I'll have 1 by 15 plus 1 by 20 plus 630, 1 by 30. So 1 by 15 plus 1 by 20 plus 1 by 30. The answer is 3 by 20. So obtaining 2 heads from 3 coins, it will be 3 by 20, and that is what he was asking us to show. Okay, let's move to the next question, B part. The B part says that draw up the probability distribution table for x. Remember, x is the number of heads when you throw 3 coins. So let me write down all the probabilities over here. The probability of having a head from the first coin is 1 by 3. The probability of having a tail from the first coin is 2 by 3. Similarly, probability of having a head from the second, probability of having a head from the second is 1 by 4. Probability of having a tail from the second is 3 by 4. Probability of having a head from the third is 1 by 5. and probability of having a tail from the third is 4 by 5. Now since we are supposed to make the table, so let me make the table first. Okay, the table will have x can take 0. Why? What does 0 means? That there is, out of the 3 coins that you are throwing, none of them is taking a head. 1, which means that one of the 3 coins is taking a head. 2, we already solved for 2, and the last is 3 because there are total 3 coins. Now we are supposed to find the probability that x is equals to x. Now let's solve it for the 0 1 first. It says that the probability that x is 0. What are the options? The option can be x being 0 means that there is no head in any of the 3 options, 3 coins that you are throwing. So it means that you are having a tail, and a tail from all the 3 coins. So having a tail from the first is 2 by 3 times 3 by 4 times 4 by 5. 4 will cancel out, this will cancel out, and you will be left with 2 by 5. So the probability for the first one is 2 by 5. The next is the probability that x is 1, and x being 1 means that out of the 3 coins that you are throwing, only one of them is a head. So what are the options that we can have? We can have a head, tail, or we can have tail, head, tail, or we can have tail, and head. So the first one is head, which is 1 by 3, followed by tail of the second, 3 by 4, and tail of the third, which is 4 by 5. Or means add tail of the first, which is 2 by 3, times head of the second and tail of the fourth, which is 4 by 5, plus tail of the first, which is 2 by 3, tail of the second, which is 3 by 4, head of the third, which is 1 by 5. If I simplify, this will cancel out, this will cancel out, these two will cancel out. I'll be left with 1 by 5 plus 2 by 15 plus 2 by 20. So 1 by 5 plus 2 by 15 plus 2 by 20. The answer is 13 by 30. So 13 by 30 for this one. We already calculated for x being 2, and that was 3 by 20. So this is 3 by 20, and the last is x being 3. So let's calculate for x being 3. X being 3 means that out of the 3 coins that you are throwing, all the 3 of them are having a head. So it means head followed by a head followed by another head. So the first head is 1 by 3, second is 1 by 4, and the third is 1 by 5. So it will be 1 by 3 plus times 1 by 4 times 1 by 5. It's 1 by 60. This is 1 by 60. Okay, the third part, C part says, given that E of x is 447 by 60, find the variance of x. So for finding the variance of x, let me make a small table first. Let me make a small table. Basically, I have to copy the same table. Let me copy it from here. Okay, let me tell you why did I copy it. I have to add another column at the top, which is x square. X square means that I will square the values of x, which is 0, 1, 4 and 9. Okay, and let me write the formula for variance. Variance of x will be equal to summation of x square probability of x minus the expected value of x whole square. Now for the first portion, we'll simply multiply the x square with the probability step by step, and we will add them as well. 0 times 2 by 5 plus 1 times 3 by 30 plus 2 times 3 by 20 plus 3 times 1 by 60 minus, we'll add these all first together, and from this value we'll subtract the mean square, which is 47 by 60 whole square. So 0, it will be 3 by let me put it directly in the calculator. It will be 3 by 30 plus 6 by 20 plus 3 by 60, and the answer is 9 by, it's 3 by 30, and it's these are values, are squared values na? So this is 4 and this is 9, so it has to be 9 and this has to be 12. So it's 17 by, it's 13, this is 13, this is 13, so this is 13, it's 71 by 60 minus 47 by 60 whole square, which is 2209 divided by 30, 600. So 71 over 60 minus this, it will be, the answer is of the variance is 2051 divided by 30, 600. Okay, let's move to the next question. Question number 2. Question number 2 says, last year an online store sold a large number of computers. 55% of the computers were made by company F. Okay, so 55% were made by company F, 30% were made by company G, 15% were made by company H. Okay, a random sample of 30 computers who each bought a computer from this store is chosen. So 3 customers are there, and each customer is going to buy it from a different store. Find the probability that 3 customers bought computers all made by different companies. Okay, so basically we need to find out that all should be made by the different companies. This is an important word. So we need to find out the the probability of having like selecting the F company is 0.55. The probability of selecting it from the G company is 0.3, and similarly for H company it's 0.15. So since he has to select from all the three different companies, one from each different company, so it will be 0.55 multiplied by 0.3 multiplied by 0.15 multiply by 3 factorial. Why? Because this option can alter as well, na? Because if the first is selecting buying from the company F, he might can buy from company G, he might can buy from company H, so the different options can be 3 factorial. So it will be 0.55 times 0.3 times 0.15 times 3 factorial, which is 297 by 2000. The next part, B part, question number 2, a random sample of 12 customers. So total number of customers are 12. So the value of n is 12. Who each bought a computer from this store is chosen. Find the probability that fewer than 10 of these customers bought a computer made by company F. Okay, so how many of them are chosen? From the 12 customers, fewer than 10. So the question is simply very simple, and the question is related to the binomial. For the binomial, we need to know the probability of success and the probability of failure. The probability of success being here will be the probability of F, because he is selecting from the company F. The probability of selecting from company F is 0.55. So the probability of failure will be 0.45 from company F, and the total sample is 12, and he is asking you to find out the probability of the customers, probability that fewer than 10 of these customers bought a computer made from company F. So fewer than 10 from these 12, we need to find the probability that the customers are fewer than 10. So it means it can be 9 customers, it can be 8 customers, it can be 7 customers, it can be 1 customer, or it can be a 0 customer as well. This is one way of doing it. We have to find the probability of each one of them, 9, 8, 7, 6 and so on, and we have to add them together. Or there is another option. We know that the sum of the probabilities is 1. So what we can do is we can 1 minus the probability of x being greater or equal to 10. Greater or equal to 10. So how can we find out the probability of x being greater or equal to 10? Let me write it here. 1 minus, first one can be x being 10, the second can be x being 11, and the last can be x being 12, because there are from the total sample space of 12 customers we are selecting. So it will be 1 minus, how can we have 10? It will be 12 C 10. Success probability is 0.5, 5 to the power of 10. Failure probability is 0.45 to the power of 2, plus the second is 11, so 12 C 11. Success probability is 0.55 to the power of 11 times failure is 0.45 power 1. Similarly 12 C 12 0.55 to the power of 12 into 0.45 to the power of 0. Now we'll simplify. 1 minus bracket 12 C10, it is 66, and 0.66 into 0.55 to the power of 10 into 0.45 to the power of 2. So it is, let me write it in the next line, 1 minus 0.03385 plus 12C11, which is 12 bracket 0.55 power 11 into 0.45. It will be 7.5286 into 10 to the power of minus 3 plus 12C12 is 1, and multiply by 0.55 to the power of 12, which will be 7.66217 into 10 to the power of minus 4. We'll add 7.52286, 10 to the power of minus 3, and we'll add 0.03385. So it will give us 1 minus 0.042139. So if I subtract 1 minus this, it will give me the probability, which is 0.958. Okay, this was the end of B part. Oh, there is a C part as well. The C part says a random sample of 140 customers. Okay, so N value is 140. N is 140. Who each bought a computer from this store is chosen. Okay, now we know use a suitable approximation to find the probability. So since it's written that it's use a suitable approximation, so it's simple, and since the value of N is very large, the value of N is very large, and he has used the word suitable approximation, so we are going to convert the binomial into normal. We'll convert binomial into normal, and you need to find the probability that more than 24 of these customers bought a computer made by company H. So basically we need to find out the probability that X is greater than 24. X being greater than 24 means that X can be 25, X can be 26, and X can be 27, and we have to find the probabilities up till 140, because the total sample space, so total samples of the customers is 140. This so the number of times you have to apply the binomial is very large. Number of times you will apply binomial is very large, so we'll convert it into normal. So how we'll do that, let's see. There is another way of checking as well, let me tell you. Just give me a while. So the value of N is 140. The probability of success, it's H, so H was 0.15, so 0.15, and Q is 0.85. Now we know that in binomial we write it as 140 times 0.15, but we convert it into the normal. How will we do that? Let's find out the mean, and mean is also going to tell us that if it's possible or not. So n times p, we have n which is 140 times 0.15, so 140 times 0.15, it's 21. So for having if the value of n times p is greater than 5 or n times q is also greater than 5, then we have to convert it into the normal. So now let's find out the standard deviation, standard deviation as well. Square root of n times p times q. N is 140, p is 0.15 and q is 0.85. So it will be 140.15.85, which is square root of 17.85. Now now let's write down in the normal way. Normal will be mean times variance. This is variance. This is variance. Okay, now let me just write down the steps as well. Steps of conversion. What are the steps, so that it's easier for you to do further past paper questions as well. The first step is that you find mean, which is the mu that we found in the first step. The second is to find out the standard deviation, which is we found out NPQ. The third step is to do the correction. I'll tell you how to do the correction. Just give me 1 minute. So these are the steps for conversion. Now, since we were supposed to find out the probability that x is greater than 24, so we need to do the conversion as well. Let's do the conversion. The third step, which is conversion. Whenever you want to do conversion, always make a small line like this, make a box, and on this box, in the middle of this box, write down the value that is given to you. Since it's 24, on the right hand side write down 25, and the left hand side write down 23. These values are 23.5 and this value is 24.5. Since it's written in the question, it is greater than, so it means that it has to be to the right side. Since it's greater than 24, so it has to be the right side. So this is the first step of conversion. So since why? Because 24 is not included, na? So 24 is not included. So this was the first step. The second step is let's do the standardization. Let's do the standardization. For standardization, z will be equals to x minus mu divided by sigma. Okay, now we know that we need to find out the probability that x is greater than 24.5. So let's find out this first. For finding x is basically 24.5 minus mean we just found out, and the mean was 21, and the standard deviation we found out. The standard deviation was square root of 17.85 square root. This was the z. Let's find the z. 24.5 minus 21 divided by square root of 17.85. That is, so it's basically probability of z to be greater than 0.8284. So that's what we need to find out. Let's go to the table. We need to find out the greater portion. For the greater portion, if I make graph, explain it to you with the help of the graph. It says 0.8284. So you basically need to find out the greater region, which means this region. So what you are supposed to do is 1 minus the table value of 0.8284. Let me find out the value from the table of 0.8284. 0.8284 will be yes, it will be 0.7961. so if I subtract it from 1, it will be 1 minus 0.7961, which is 0.2036. If you are confused about how to take a value from the table, please leave that in the comment section. I'll make a proper video so that it's easier for you how to identify the value from the table as well. And let's move to the next question, question number 3. Question number 3 says the length of 250 leaves of a certain type of a plant are measured. Correct to the nearest centimeters. The results are summarized in the table below. Okay, this is the table. It has the frequency and in the first part he asks you on the grid below, draw a cumulative frequency graph to illustrate. So for finding out making the cumulative frequency graph, let me complete the table first. For the table, I have to, can you see there is a gap between the upper class and the lower class of the consecutive values. So I have to find the difference and divide it into half. So it will give me it will make it 0.5 difference. So the first one will become from 4.5 till 9.5. The second one will become 9.5 till 14.5. Third will be 14.5 till 19.5, 19.5 till 24.5. This will be 24.5 till 29.5, and this will be 29.5 till 39.5. Since we are supposed to find out the cumulative frequency as well, and for the cumulative frequency, remember what you do, you always add the frequencies that are coming afterwards. So for example, in the first one you will write down 18 as it is. As you go to the next column, just keep adding the next frequency into the previous cumulative frequency. So it will be 18 plus 28, which is 46. Now just add the next frequency into the existing cumulative frequency. So 46 plus 60 is 106, plus 72, 178. So 178 plus 48, which is 226, and add the next 24 into it as well. So it will make it 250. This is an easy way to check that if the last value matches with the total frequency given in the question, it means that you have added the cumulative frequency correctly. Okay, so let's move to the making of the graph. We don't have the grid up with us. So for finding the grid, it's easy. You should always remember that the cumulative frequency has to come on the y-axis, and whatever thing is given in the first column, it always comes on the x-axis. So let's write down that the length is going to be on the x-axis, length in centimeter, and cumulative frequency will be on the y-axis. Now we have the x-axis. I'll tell you how to find out the value, the x-axis and the y-axis readings as well. Just give me a minute. Okay, now just have a look that what is the highest value that you need to have on the y-axis. That is 250. This is the highest value that you need to have on the y-axis. So what you should do is just count the number of boxes. 1, 2, this is 1, 2, 3, 4, 5, 6. So divide 250 by 6. 250, if you divide it with 6, it gives me 42. 42 is not a good figure to write off. So what you should do is you should write 50-50 gap of each. 50, 100, and 150, 200, and 250. It's totally perfectly fine if you are covering 3/4 of the graph. The next is the x-axis. The x-axis is the maximum value on the x-axis that you need to write is this one, that is 39.5. So let's make it 40 roughly. How many boxes do I have? 1, 2, 3, 4 boxes. So 40 divided by 4 boxes, that makes it 10. So let's make each box of 10, 20, 30 and 40. This is the x-axis and that's the y-axis. Now for the cumulative frequency, always write down these values in the coordinates form. How do you write these values in the coordinate form? Remember, this first value is going to go with the 0, so it will be 4.5, 0. The second value is going to be the ending values and the cumulative frequency. Ending value of the length, it is going to be the x value, and the cumulative frequency will be the y value. Let me write it in the coordinates form. It will be 9.5, 18. The next will be 14.5, 46. The next will be 19.5, 106. 24.5, 178. The next is 29.5, 226, and the last is 39.5, 250. Now let's plot all these values. 4.5, 0. 4.5, 0 will be 1, 2, 3, 4. 4.5, 0 will be here. The next is 14.5 and 46. 14.5 and 46. 1, 12, 13, 14, 14.5, and this will be 50 divided by 10. This means one box is of 5, 5. 50 is the gap between the values and 10 are the small boxes. So 5, it will be 45 over here, and so it's right here. 14.5, and there's 19.5 and 106. So 19.5 and 106 right here. 24.5 and 178, 24.5 and 178, 160, 170, 175. Okay, and it was 24.5. It's 21, 22, 23, 24, 25, 4.5. The next is 29.5 and 226. 29.5. 29.5 is here, and 5, 10, 15, 20, 25, and this. The next and the last is 39.5 and 250. 39.5 and 250 will be right here. So for the cumulative frequency, it always have to be a S-shaped curve. If you connect all these together, okay, remember it has to be a S-shaped graph. It always is supposed to be a S-shaped graph. Okay, now let's move to the next part, B part. It says 38% of these leaves are of the length k centimeters or more. Use your graph to find an estimate for k. So 38% of these leaves are of the length k centimeter or more. So let's first of all find out the 38% of the leaves. So 38% of 250, because that's the total that we have. 0.38 into 250, that makes it 95. So 38% of these leaves are of length k centimeters or more. So 95 of, let's go to the 95 first. So k percent of these leaves are of the length or more. So basically we need to subtract it from the total as well. So it will be 250 minus 95, which makes them 155. Now let's go to 155. So on 155 we'll see what is the length. So the length on 155, that's somewhere 23. So estimate the value of k. The value of k is 23.5, or you can write it as 23 as well. Both are correct. Calculate an estimate for the length, for the mean length of 250 leaves. So for finding out the mean length, we have to make a table. Let's make a table first. The table so that it's convenient for us. In the table, what are the values that we are supposed to have? Let me write them here. The first value will be the length, and in place of length, remember you are going to write down the mid values. And why are we writing the mid values? I'll tell you, because it is the interval. Whenever it's the interval, you always write down the mid value. So what is the mid value of 4, 5 and 9? 5 and 9 mid value you can calculate by adding 5 and 9 and then dividing it with 2, which is going to be 7 in the first case. You can do it for the remaining as well. It will be 12. For the second, it will be 12. The third, it is going to be 12. It is going to be 17. And after 17, 22. Followed by that, it is going to be 22, 27. It is 27, and the last will be it is 30 or 39. 30 and 39. So 30 plus 39 divided by 2, which is 34.5. So what's the frequency for all of them? The frequency is 18, 28, 60, 72. 18, 28, 60, 72, 48 and 24. 48 and 24. We have to make a new column at the bottom, which is going to be fx. For fx, you just need to multiply 7 and 18. 7 times 18, will be 126 for the first. 12 times 28, which is 336. 17 times 60, which is 1020. 22 times 72, 1584. 27 times 48, 1296. 34.5 times 24, which is 828. Now what's the formula for mean? Mean is SFX or sigma fx over sigma f. So sigma fx means you need to add 126, 336, 1020 and 1584, 1296 and 828. We have to divide them by the frequency, that is 250. It is always mentioned in the question. So let me add them together. 126 plus 336 plus 1020 plus 1584, 1296 plus 828 divided by 250. Okay, so it will be 5188 divided by 250. So if I further, it is 220.76 centimeters. This is the mean length of the leaves. Let's move to the next question. Question number 4. Question number 4. Okay, let's move to the question 4. Question number 4 says Eddie has 16 toy cars, of which 8 are white, 8 are white. White are how many? White are 8. The total cars are, toy cars are 16. White are 8, black is 5, silver is 3. He places all the cars in the bag and sets 3 of them at random. Okay, he is selecting 3 of them as random, but he is selecting without replacement. Find the probability that all the 3 cars are of same color. So probability of same color, what are the options that we have? We have white, 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 or we have black, 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 or you have silver, silver and silver. So what's the probability? Remember, it is a without replacement question. You are not putting the toy car back into the bag. So the first white is going to be 8 by, total cars are 16, multiply by the second white will be 7 by 15 times 6 by 14. Now for all the 3 to be black, it's 5 by 16 times 4 by 15 times 3 by 14. This is for the, this was for the black. For the silver it will be 3 by 16 times 2 by 15 times 1 by 14. If I simplify, it will be, this will be 1 by 2, 1 and 2, 5 times 1, 5 times 3, 3 times 1, 3, 1, 4 times 1 and 4 times 4, 3 times 1, 3 times 5, 5, and this will be 7. So it will be, if I write down the simplified version, and this can be further simplified, 2 times 3 and 5, so it will be 1 by 10 plus 1 by 56 plus 1 by 1 times 560. So let me find the probability. 1 by 10 plus 1 by 56 plus 1 by 560. The probability of same color is 67 divided by 560. Let's move to the B part. The B part says find the probability that when the three cars are selected, at least one car is white and at least one car is black. So one car is white and the one car has to be black. So let's write down the options first. It can be white, black, they have to be there at least na. So there can be one silver. The other option is that there is white and black, or the last option is that we have white, black and black, because there is no rule that there is no we cannot drop either a white or a black. There has to be one. So this is the option that we can have. So how many options can we have from here? We can have 3 factorial options from here. How many options can we have from here? 3 factorial. How many total arrangements can we have from here? 3 factorial. Okay, and since there is a repetition in the first one, over here there is a repetition of white and white, which means we'll divide this by 2 factorial, and there is a repetition in this one as well of black and black, that is also the same as 2 factorial. So so this is basically the arrangement inside all of them, and this is basically the repetition. Okay, now let's write down the probability for that. It is going to be 8/16 times the black is 5/15 times 3/14. This is the probability. How much factorial it is? 3 factorial. Multiply by the second option that we have is 8/16 into 7/15 into black is 5/14, and the arrangements that we can make is 3 factorial divided by 2 factorial, because there is a repetition. The last is 8/16, black is 5 and then 4, 15 and then 14, and there is further arrangements can be 3 factorial over 2 factorial. So if you simplify, it is going to be the first one is giving us 3/14, the second one 8/16 times 7/15 times 5 it's giving me 1/4, and the last is 8/16 5/15. This 3 factorial divided by 2 factorial, it is giving us 1/7. So if you add them all, it's 3/14 plus 1/4 plus 1/7, and it's giving me 17/28. This was the B part. Let's move to the next part. Next question. Question number 5. Question number 5 says that the mass of peaches sold per day in a supermarket is normally distributed with the mean of 65.8 kg and the standard deviation 9.6. So since it's a normal distribution, so let me write it as 60.5.8, 9.6. Find the probability that the mass of peaches sold on any given day is between 56 and 75. So basically we need to find the probability that the mass is between 75 and 56. 75 and 56. So the first step that we are going to do is standardization. I hope you remember how do we do standardization. We'll find z, and that is x minus mu divided by standard deviation. So that's the first is 75 minus the mean is 65.8 divided by 9.6. So 75 minus 65.8 divided by 9.6, which is 0.9583. The other z value will be, let me find the other directly, and let me change 75 by 56, and the answer is minus 1.020 minus this will be 1. So after doing the standardization, it will become probability of minus 1.021 less than z less than 0.9583. Now we need to find the probability of this. So let me make the graph of this first so that it's easy for you to visualize. We always make a graph for normal distribution so that it's easy for you to visualize. We need to find out in between. One value is negative 1.021, the other value is 0.9583. So basically you need to find out the probability in this region. But for this region, how can we do that? It's so simple, it's easy. How can we do that? We first of all find out we can find out the total probability of under the region behind, because we know that the table that only gives us the probability on the left hand side of the graph. So it will be, and the negative values are not there on the table. So let's first of all find out 0.9583 this region on the left hand side. Let's find out the total probability for this region without excluding any portion from here. So if I find that from the table of 0.9583, it will be 0.8309. This is the probability for this region, but we know that we are not interested in basically this portion of the graph. So how can we find out this portion? See, this portion will be, if I flip this graph right here and it comes 1.021, and this is the portion on the right hand side. So how can we find out this portion from the graph? It's simple. We first of all need to, for finding out this portion of the graph, we know that the total probability is 1, and if I find out the probability of 1.021 from the table, it is going to give me this portion of the graph. So for finding out this portion, what I can do is 1 minus the probability of 1.021. So 1.021, it gives us 0.8463. So 1 minus 0.8463, it is 0.1537. So this portion is basically 0.1537, and the total probability is already known. So we can do is minus 1.021 less than z less than 0.9583. what we can do is total probability is 0.8309 minus 0.1537. So 0.8309 minus 0.1537, it is 0.6772. This is the probability. Let's move to the next part. The next part says that the mass of cherries sold per day in a supermarket is normally distributed with the mean of this and the standard deviation of this. It is known that 10% of days less 10% of days less than 59.1 kg of cherries are sold. Find the value of the standard deviation. Okay, so basically this is the normal distribution with the mean value 72.4 and the standard deviation unknown. And we know that from the previous part, we know that we already have it here, that it says less than 59.1 kg. Yes, he says that it's less than 59.1. the probability is 0.1. so by that means we need to find z, and z will be equals to x minus mu divided by standard deviation. So the value of x is 59.1, the value of mu is 72.4 divided by the standard deviation is unknown, 59.1 minus 72.4, which is 13.3. so basically z to be less than minus 13.3 divided by standard deviation, it has to be equal to 0.1. The next step, always remember to label this thing, always should be labeled as a. So if you label that as a, it will be minus a equals 0.1. Now if you make a graph of this, how does the graph of this looks like? Since it says negative 0. So it will be minus a, and 0.1 means that this is the probability. This is the probability as 0.1. This probability is 0.1 basically. Now what you can do is, so find out this probability, you basically need to basically first flip this thing. So how do you flip it? How are you going to flip it? This is going to become like this, because the table does not give the negative value. It is going to become a positive value, and we are interested in this portion, and this portion is basically 0.1. This portion is 0.1. so what we can do is, we know that if we find the phi of a, it will be 1 minus 0.1, which will be 0.9. so what we need to do is, we need to do the phi inverse. So phi inverse, if you look at the table, phi inverse in the table, if you look at it, it is given directly in the table as 0. It is always given directly in the table. If you need to do phi inverse, if you need to find out phi inverse, it is going to be given directly in the table. For this case, it is given to be minus 1.282. This is the value of a that we have. So the value of a will be minus 1.282. Yet we are not done. We are supposed to find out the standard deviation. So we know that a was equal to minus 13.3 divided by standard deviation. So standard deviation will be minus 13.3 divided by minus 1.282. So 13.3 divided by 1.282, the standard deviation will be 10.37, which is 10.4. so this is the standard deviation. Let's move to the next part. The next part says that the supermarket is open 7 days a week. Find the probability that in a randomly chosen week, the first day on which less than 59.1 kg of the cherries are sold is the 5th day of the week. So this is the geometric distribution. So for the geometric distribution, we need to have x will be equal to r. So x stands for success and r stands for the number of number of repetition until you have the success. So the formula is q power r minus 1 into p. The p is basically it's 0.1 and q will be 0.9. So it will be 0.9 to the power of 4 and 0.1 to the power of 1. 0.9 to the power of 1 into the probability will be 0.0656. The D part says that find the probability that in a randomly chosen week, the first day on which less than 59.1 kg of cherries are sold is before the 5th day of the week. So before the 5th day, it's simple. So it has to be less than 5. But remember, we cannot solve it. It has to be either because this is the condition that we are supposed to have. The probability has to be less than and equal to r, for which the formula is 1 minus q power r. The other condition that we should have is probability of x being greater than r, in which case we will put q power r. So both of these are not the possible cases, but we know that x to be less than 5 means 1, 2, 3 and 4. So what we can do is we can write it as probability of x less than and equal to 4. So x is less than and equal to 4, it will mean 1 minus q power r. So 1 minus the probability, the q is 0.9, r is 4. So 1 minus 0.9 power 4, it is 0.3439. Let's move to the next question, question number 6, and yeah, that would be the last question. Alyssa has 10 different books from the series Square and Circle. The books looks similar except for their colors. There are 3 blue books. So blue books are 3, red books are 2, yellow books are 2, orange books is 1 and purple is 1, green is also 1. Alyssa places the books in a row on her shelf. She is only interested in the arrangement of the colors, so it's simple arrangement. Okay, so for simple arrangement, permutation, how many different color arrangements are there for the 10 books? So simple, it's 10 factorial because there are total 10 books. And how many books are repeating themselves? It is 3 factorial times 2 factorial times 2 factorial. Blue, red and yellow, all the 3 were repeating themselves. So it is 2 factorial times 3 factorials times 2 factorial. So 10 factorial divided by 6 times 4, which is going to give me 151200 arrangements. These are the total arrangements that they can make. This question is permutation because simple word of arrangement is being used. The B part, how many different color arrangements are there of the 10 books in which 3 books, blue books, are supposed to be together? Let me 1, 2, 3, 4, 5, 6, 7, Okay, from these 10 books, 3 blue books are supposed to be together. So 1, 2 and 3. On these 3 shelves there is supposed to be blue books, but the 2 yellow books are not next to each other. So not next to each other. First of all, let's find out the total arrangement. For the total arrangement, 1, 2, 3, 4, 5, 6, 7 and 8. So total there are 8 factorial divided by how many of them are repeating. There are 2 factorial for yellow and the 2 factorial for the other ones which are over here, yellow and the red one. Yes, the red one. So 8 factorial, let me write, one for red repetition and the other for the yellow repetition. So 8 factorial divided by 4, it will be, total arrangement will be 10080. So he says that 2 yellow books cannot be next to each other. So there is one way that we need to find out the yellow books cannot be together, na? But the other possible way is that we find out that how many total arrangements can we have in which the yellow books can be together. So if the yellow books can be together, let me write the yellow books are together over here. So how many total arrangements can we have? Yellow together. For yellow being together, it will be 1, 2, 3, 4, 5, 6, 7. Total arrangements are 7 divided by how many repetitions? Just 1, which is 2 factorial. So it will give us 7 factorial divided by 2, which is 2520 arrangements when the 2 yellows are together. They are next to each other. But since we are interested in the yellows not being together, so what we can do is we can subtract not together arrangement. So not together arrangement will be total arrangements minus the yellow arrangements together. 10080 minus 2520, which will be 7560 arrangements. Okay, the next part, the second last part of the paper, which is C part. How many different color arrangements are there of 10 books with exactly 4 books between the 2 yellow books? Okay, so let me make the 10 books first. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, he says that how many different color arrangements are there of 10 books with exactly 4 books between the 2 yellows. So what we can do is we can make the 2 yellows 1, 2, 3 and 4 and this yellow. So these are supposed to be together, he says. And how many arrangements can we have is, let's see, he says this is 1, 2, 3, 4 and 5. There are total 5 arrangements that we can have, and total arrangements, remember these books can also switch, these 4, 5, 6, 7 and 8. Remember these the blue crosses that I have made, these can switch with each other here and there. So total arrangements of these books that we can have is 8 factorial divided by how many books are repeating over here? 3 red and 3 how many of them are repeating? 3 red and 3 blue are repeating over here and 2 reds are repeating over here. So 3 blue and 2 reds are repeating over here, and we will multiply it with 5. And why not 5 factorial? Because 5 factorial means that we are basically not arranging the cross places. Since we are already considering the cross places in 8 factorial portion, so there are not further arrangements that you need to make. So why? Because this is one box that this box can have, this is the second place this box can take, this is the third place this box can take, fourth place and the fifth place. These are the only places this box can take. So these are not 5 factorial, this is just 5. So if we multiply it, it will be 8 factorial divided by into 5. That makes it 16800. Let me recheck. Multiply by okay, let's move ahead. It gives okay, last part. Alyssa selects 4 books from 10 different books from the series Square and Circles. Find the number of different selections if the 4 books include at least one red book. It means that the red book has to be greater or equal to 1, at most one blue book. So blue book has to be less than or equal to 1, and exactly one yellow book. So it means the yellow books is supposed to be just 1. Let me write it here. Blue was 3. There were all red 2, yellow 2, red 2, yellow was 2, and the remaining, how many remaining? 1, 2 and 3. 3 remainings. Others, they are total 3, which are basically purple, green and orange. So what options can we have? We can have is, the first option we can have is yellow, which has to be exactly 1, red, blue, and it can be any other. The second option that we can have is yellow, red can be 2 as well, because it's at least one red, and it can be any other. Yellow has supposed to be there, it can be any other. Third option that we can have is it can be yellow, it can be red, and it can be blue. The fourth option can be yellow, red, it can be any other, and other. This can be the options that we can have. So how many total possible options we can make from the first one? It will be 2C1, because 2 yellows are there and we are selecting just 1, times 2 reds are there and we are selecting 1, times how many blue are there? There are total 3 and we are selecting 1. There are total 3 others and we are selecting 1. Similarly, yellow for the next, it is 2C1, 2C2 times 3C1. Now the next is 2C1, red is 2C2, blue is 3C1, and the last is yellow is 2, out of which we are selecting 1, red is 2, out of which we are selecting 1, other is 3, we are selecting 2. So it will give us 2C1 times 2 times 3 times 3, which is 36 for the first one, and it is 2 times 1 times 3, which is 6 for the second. The next is 2 times 1 times 3, which is also 6. 2 times 3c2, which is 3, which makes it 12. So the total will be 36 plus 6 plus 6 plus 12. So 24 plus 36, which makes a total of 60 total number of different arrangements or selections you can make. I hope you have understood all the questions. If there is any query regarding any question, please do feel free to leave it in the comment section. I'll try my best to respond it as early as possible. I hope you have understood all of them. Please do share the video with your friends, so that it help me also to grow my channel, as well as it support others and benefit others as well. Do check out other videos for your if there is any concept that you are lagging behind, please leave that also in the comment section. I'll make the video as early as possible. Thank you. Good luck.